All right, guys, we are moving into the last leg of the lecture series. Thanks goodness, thank goodness, thank goodness. And we just got a little bit of nuggets of information that we need to talk about and that we need to go over. And we ended up with the idea of a hydraulic. And a hydraulic was almost like a pneumatic in a way, right? A pneumatic used air and it pushed air and it was using air to do some type of work. And a hydraulic is using hydra, which is water or some type of fluid in order to do work. So that's really the only difference there between a hydraulic and a pneumatic definition that we talked about many videos earlier. So now I want to kind of end up the utility section with something that we're all familiar with, and that's electricity, right? So we need electricity in order to operate our homes and in order to power my TV and in order to do all the nice little things that I need to do at home, including charging a cell phone. Yes, I do use one. I don't keep it with me, but I do use it and I do have to charge it sometimes. But electricity is going to be very important, not only for us, but also for biomanufacturing as well. So there's actually 3 different stages of electricity that we need to mention briefly, but only one of them really is going to be the kind of the most important. The first one is a high voltage, and a high voltage is really referring to quite a large range of what we would call volts, and it goes from 12,000 to 138,000 volts. This is way too much in order to do things with safely, and this is typically what you would see with main power lines. So if a main power line, power is getting generated, electricity is getting generated somewhere, it's got to be carried, and the main power lines are going to be carrying that, and it's got to be quite a hefty number of volts because it's got to go to a number of different locations to be used. So high voltage is really nothing that we're too concerned with, and that's because these are normally things that are being done by the power companies, not by the biomanufacturing facilities and not by locations, even like the college, that we don't need that much, okay? So there's often like a power station nearby, and those power stations take that really high voltage and it lowers it down. So that way it becomes a little bit more safer for that particular local area or that local region. And that's kind of the purpose of a power station. And those power stations are normally scattered throughout, right? So there's a number of different power stations that will take this really high voltage and lower it down for us. Next up is medium voltage, and the medium voltage carries around 480 volts, and that medium voltage is going to be used to drive these huge motors. So drive pumps, hoist, other types of equipment, that's what's going to be using the medium types of voltage that's out there. So again, we're talking about things that are quite large, that do a lot of work, that do a lot of hefty lifting or movement or something for us. Those are not going to be able to be plugged in to a normal outlet. You cannot take a coffee maker and plug it in to one of those outlets. It's not going to work, okay? So because of that, medium voltage is going to be needed, and those power adaptations are going to be slightly different on those pieces of equipment as well. So that's really not what we would see a lot of. I mean, it's there, it could be present, but for the most part, what I'm going to see on the manufacturing line is everything that we would deem as low voltage, which is 50 volts or less. And this is kind of what's used throughout the entire facility. So a lot of the equipment's going to be based off of it. A lot of the processing pieces are going to be based off of it. A lot of the laboratory instrumentation is going to be based off of it. Control rooms, computers, lights for the ceilings. I mean, everything from a regular power outlet is going to be relying on the low voltage type of scenario. So again, 50 volts or less is normally what we are seeing here and what we are using on a daily basis. We do have something called UPS. Oh gosh, no, that's not going to deliver your packages. That's not the UPS. That's not what we're talking about. UPS is uninterruptible power supply. So there's a chance. I mean, keep this in mind, right? So let's say I'm working in biomanufacturing and I've got these fermenters, and these fermenters are connected to other types of containers and situations where we're doing some cleanup stages, and those cleanup stages are going from vat to vat to vat to vat, and then sooner or later we're putting them on the production line where they're getting bottled, where they're getting labeled, where they're getting boxed. I mean, this process goes on and on and on throughout the day. Okay, well, what if We just get a power outage. What goes on? How do we manage this type of situation? This is not good, as you can imagine. I mean, a lot of my things are relying on pressures, they're relying on temperatures, they're relying on heaters and coolers. I mean, everything that we've talked about, keep that in mind. Everything that we've been talking about, it requires some form of electricity probably in order to do that job. So how on earth do we keep this process up and going? So we've got to have a backup. So one of the backups that we can have is called an uninterruptible power supply. So I want you to think of this as almost like a little temporary battery pack. And that's the thing with this UPS design, this short-term backup generator. Now, do they call them UPS? Well, sometimes they all call them the UPS, but UPS or uninterruptible power supply is what this is for. So I want you to think of like momentarily losing power, and you're not fully disconnected for long periods of time, but you get a little glitch or you get a little surge maybe, and it just whacks everything out momentarily. So the uninterruptible power supply, UPS here, is going to be able to step in, and it will take over, and it will be almost like a little house generator. It will just continue to power and continue to operate the things that need it, but we are talking about the basics of the basics. We're not talking about everyone in their little private office is going to have all the power that they want. That's not the purpose of these power supplies. These are meant for short term. They're meant for things that are very specific, so that way they can keep working and keep doing what they need to do. Now, in addition to this, you will also see companies that will have a entire generator, backup generators that will operate the laboratory spaces, that will operate the manufacturing spaces. Those generators, that is their purpose. Their purpose is to keep things on board, keep things running, keep things going, so that way we can give the electric company enough time to figure out what the problem is so they can come out and repair that situation and get us fully back up and running. So generators are a have-to. Generators can be found, absolutely, but we also have these little short-term power supplies that can be used as well if the power doesn't stay out for long periods of time. But again, they don't power the entire facility. So as far as me and a job of a technician, what should I be doing if I go out and I'm working with electricity? Number one, you want to make sure that the disconnect switch is on. This is like a circuit breaker. Your circuit breaker should be on. So these little power switches at some of this equipment, they also need to be on. So you just want to double check them, make sure they're running the proper way, make sure they're getting power, make sure that they're there and they're working the proper way. So that way they can flip when things get out of hand and it turns the power off. So those are things that need a little bit of maintenance to them. Second, observe abnormal conditions. So do things smell funny? Do they sound funny? Is smoke getting generated? That could be an electricity related problem. So you want to make sure that you double check all of these, keep all of your senses intact, because that is very important. Number three, inspect damage. So electricity is carried with the help of some wires. And you want to make sure that these wires are not frayed, that they are not severed, that they're not damaged. You want to make sure that they stay clear of any type of fluid like water, because these can cause a problem, and these problems can be quite large, and I don't want to get electrocuted. So high voltage here, you kind of want to keep that in mind. And when I say high voltage, I'm not talking about the high voltage that we just discussed. I'm talking about, okay, I'm going to stick a knife into a power outlet at 110 volts. Okay, well, good luck with that, all right? Number four, use correct voltage. So you want to double check, make sure things are powered the way that they need to be powered. A lot of times this is already hooked up, it's ready to go, it's running smoothly by the time I get there. So I just want to make sure that that continues to hold steady, right? Hold the fort down. That's what we're kind of doing. Number five, again, avoid water These are problem areas, and I want to make sure that any of those spills, any of those leaks are taken care of quickly, because this can lead to bigger problems down the road. Number 6, avoid shocks. So shocks are going to be important as well, because it's very easily to get electrocuted. And sometimes that electrocution can send you to the hospital or can kill you, depending on how much it is. So I want to be really careful of this, making sure that I'm taking the special precautions that I need. Number 7, malfunctioning equipment. If something does not start, please do not try to start it. Please do not force it into operation. There could be an electricity problem. It could be a power problem. And you want to make sure that those things are fixed before you go any further, because that is an issue if you're not very careful. All right. Okay, so that's my story with electricity. And then finally, here in the last part of this, we want to talk a little bit about waste. I hope that I've not wasted your time. I've hoped that I have not wasted my time. I've hoped that you've watched these lecture videos and that you've learned something from them. But that's not really the waste that we're focused on here. The waste that we're focused on here is all the trashy little stuff that can be dumped outside that we are generating. And how do we handle that? Where does it go? How do we process it? That's the waste that we're referring to. So there's different types of waste, as you can imagine. Of course there is. There's non-hazardous waste, and then there's hazardous waste, and then there's biological waste, and then there's heat waste. So there's different ways that we handle each type of these scenarios and classifications. As you can imagine, non-hazardous waste, that would be kind of like you at your house. Most of the time you are generating waste and it's non-hazardous, and you put it into a trash bag, and then you put it into your trash can every week, and they come and pick it up and they go dump it off at the landfill probably. I mean, that's non-hazardous. But there are certain things that are hazardous, and we've got to process those safely. We've got to get rid of them in a safe manner. So how do we do that? Well, we take them to specific drop-off locations, or we process them. If I'm a biomanufacturing company, we process them in-house using certain protocols that I need to follow to make sure that they're clean, so we can dump them a little bit later down the road. Biological waste is just that. It's anything biological in nature. If we are using a biological to grow cultures, to basically produce a product, well, what do we do with all of those killed dead cells that are after the fact, right? Where do we end up putting those? Can we just dump them down the drain? And the answer is no. We got to process those in a proper way. And then heat waste, we're generating a lot of heat. Of course we are. So how do we take care of that type of waste? Because it is waste by definition. So waste treatment, let's start here. First off, each step generates some type of waste. If we are not very careful, we are going to forget that, and we are going to ignore that waste is a problem, and we just kind of get rid of it after that point, and we don't think anything of it. That could be bad. So every step in the biomanufacturing process does generate some type of waste that needs to be taken care of. Absolutely it does. So how do we do that? So there's going to be procedures, right? Strict procedures. And guess what those are called? I'll give you a guess. Hopefully you got it. It's SOP, Standard Operating Procedures. So there's proper procedures in place that will tell us as workers what we need to be doing with the waste as it gets generated. Can we just dump it down the drain? I mean, if so, great. That could be a possibility. If so, great. We'll just dump it down the drain. If we can't, then what do we do in order to process that the proper way in order to get rid of it? So all of these processes are going to be kept in mind, and they are also going to put your safety first. Believe it or not, that's what they do. Yes, that is right. Because they want you to continue to work, and they want you to come into work the next day. So we want to make sure that you don't injure yourself, or we don't damage yourself in some form or fashion in the waste process of dumping and disposal of these various types of products that get generated throughout the manufacturing line. So we're going to first start with non-hazardous waste. Non-hazardous waste, very, very simple. Dump it down the sewers, dump it down the drains, let landfills come and pick it up and take it off and haul it away. Go to recycling centers or a recycling process in-house. So these types of situations are very easy to take care of. This is what I would call the regular trash of the manufacturing line. line and the laboratory facilities. This is just a regular nothing special. Just throw it away, get rid of it. I'm tired of looking at it. Let's clean house. That's what non-hazardous waste is all about. So all the paperwork that goes into the office trash cans, the bathroom water, all the flushing, the sink water, all the dumping, the cooling water that does not come in contact with active pharmaceutical ingredients. This is just water you're taking in and you're pumping out. Nothing special is happening or coming in contact with that water. That can be dumped just like regular water can be dumped. Water that's been treated to remove the impurities. So there's a chance that we do have water incoming, and throughout the process we are taking extra steps at the end of this to make sure there's no impurity that remains, that we can safely dump down the drain. That is perfectly okay to do as well. And inactivated biological waste. So if we can make sure that something has been killed and that nothing is alive and nothing is growing, then absolutely there's probably a little bit of that in my tap water as I'm getting it anyway, so we can dump it and we can get rid of it just as easily as we can at our house. Notice that water is the discussion trend here. It's a lot of water disposal, water disposal, water disposal, but any chemical, any reagent, any type of material throughout the biomanufacturing process needs to be disposed of the proper way. And if it's non-hazardous, pretty simple, pretty easy to do. If it's hazardous waste, then that means I need to take special precautions to handle it. And sometimes there are things that I can do in-house that can neutralize the threat. Okay, and this step could involve multiple steps, multiple things that I do with them. And here are just some questions that we need to ask ourselves. So hazardous waste, is it a flammable, combustible material? So is it going to catch fire easily? If so, we need to handle that with care. Is it a corrosive? And a corrosive means it eats away stuff pretty much, right? So think of the metal of your car, and that is corroding over a course of time due to some very slow chemical reactions that happen here. That's a thing. Is it reactive? So can it react with other things and do things and make products and get out of control and get out of hand? If so, we've got to handle this with care and we got to process it the proper way. And is it toxic? So is it going to do some damage to me? Whether it's acute or whether it's long-term, is it going to damage something? If the answers to any of these are yeses, then we need to probably treat them the proper way, especially if we are producing this waste in bulk. So there are things I can do in-house that will neutralize these threats so that way we can safely dispose of them. Or if there's not anything that I can do, then we probably need someone to come and pick up these waste products, and we need to dispose of them the proper way, and we let them handle it. These are controlled by RCRA, or RCRA. That stands for the Resource Conservation and Recovery Act. And it all requires paperwork, folks, as you can imagine. So if we do have to go through the process of disposal with any of these types of materials, we have to make sure that we document it. We have to make sure that we sign it. We have to make sure that we date it. We have to make sure that we initial it. We've got to make sure that we write on it what we're doing, where it came from, who picked it up, what date and time did it get picked up, how did we handle it in between. All of that does require a significant paperwork trail to show that we did what we were supposed to do when we dumped this waste, whether it's after the processing or for someone else to take care of for treatment. Hazardous waste for solids. What happens here? Well, okay, solids are going to be treated a little bit differently than liquids, as you can imagine. Solids can sometimes be PCBs, polychlorinated biphenyls, heavy metals, any type of container that comes in contact with this particular type of material, that is also treated as hazardous waste, and any material that has contacted the agent or chemical, and that includes any type of scrubbers, any type of brushes, any type of paper, and this also applies to laboratory as well. So let's say that I'm working in a lab and I'm given a sample from the manufacturing line, and this sample is deemed as a possible hazardous type of material. I want to make sure, is it there and did it get neutralized? If it is still there, anything that came in contact with that hazardous material is also deemed hazardous as well. So I need to make sure I take extra steps and precautions to dispose of that, just like the hazardous material itself. So most facilities, if they are solids, this is a very easy way to process hazardous waste. They can incinerate it. So incinerate it just basically means take it to the burners. Let it burn it off, let it char it, let it destroy the actual nature of that compound itself, and we can process that waste just as simple as that. A lot of landfills will have incinerators as well, and again, those incinerators are for solid waste. That can be a problem if we're not very careful with how we handle it and so forth. So just like before though, paperwork, 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 paperwork. Be ready to almost like buy a vehicle every single day of your life, because there's so much paperwork that's got to be signed off on in order for the treatment to happen. How is that a little different than liquids? Well, liquids most of the time are not incinerated. Liquids are processed in a different way, and one of the first ways is distillation. So with distillation, what I often see is some type of container, and then I heat that container, right? And then that will turn into a vapor. And then what's happening is that we can collect that vapor and we can let it drip back down into a liquid over here. If I work the distillation the proper way, we can do some cleanup. So what that means is that maybe the stuff that I'm stilling, maybe this stuff is good, and maybe this stuff is no longer hazardous. And I can treat that the proper way. So I can recycle it, I can reuse it, I can dump it down the drain, do whatever I want to do with it. And maybe the stuff that's left over here, maybe this is the hazardous stuff. And if so, I've separated good stuff from the bad, and that limits the volume of bad stuff that I have in-house. And when I limit the volumes down, they're going to be a little bit easier to dispose of, a little bit easier to handle. So distillation is part of that process. Number two is precipitation. So precipitation's kind of the similar idea in a way, I guess you could think of it that way. But I'll give you an example. So let's say that in a laboratory space, I've got a solution, and that solution is silver, and that carries a positive charge. Well, that silver is hazardous. I cannot dump this down the sinks. I cannot dump it down the drains. I can't really do anything with that silver at all. So I've got to treat this as hazardous waste, and there is a very creative way that we can lower the volume and lower the amount of waste that we are generating if this is part of the process. So what happens is that I will add a reagent to it, and that reagent could contain maybe something like chloride. So what happens is that silver and chloride, they madly fall in love, and they make a little molecule marriage, and they live happily ever after. Okay, well, that produces silver chloride, and silver chloride is a solid. So what happens here is that that silver chloride precipitates out, and it settles to the bottom. So now all of this liquid is probably not hazardous any longer, and as long as I test it and as long as I treat it the proper way, we can maybe dispose of that in a non-hazardous way, and I can get rid of a large amount of volume if I do that. Well, the precipitate piece, the precipitate is the piece that we've got to look at as hazardous now, because that is containing the piece that made the solution hazardous, and that's the silver. So once more, I can take the volume, shrink it down to something more manageable, get rid of everything else that's not hazardous, and now I really just have a solid to worry about if that's the case or if that's the situation. Absorption is another way that we can treat liquids, and dilution is another way that we can treat liquids. So with absorption, I want you to think of pouring stuff through some type of material, and that material can actually reach out and grab that particular maybe component that is regarded as hazardous, and it will grab it and it will hold on to it and it will not let it go. It absorbs that material in a way, okay? And then everything else that just runs through, well, if that's not hazardous, we get rid of it, we dump it, and we save ourselves a lot of trouble. So that's the absorption type of process. And then the dilution dilution is the solution. Okay, so a lot of times if it's hazardous, meaning we got to treat it in some form or fashion, we can't just dump it down the drain as immediately as it come out of the waste spout, then we will often treat it with an acid, treat it with a base, neutralize it in some form or fashion, whatever the case is, and then after that we can dilute it. So we just add a lot of water to it, and if we add a lot of water, it dilutes it, it makes it much weaker, and then it makes it safe to dump down the drain or discharge of it in some form or in some fashion. So liquids, as you can tell, have many other options that solids do, but it also requires more involvement with me than solids traditionally do. As far as liquids go, waste systems, proper waste systems, should collect and neutralize non-biological waste. And what that means is that here you see a couple of pictures. Over here on the left-hand side, you're seeing that these are feed tanks, and those feed tanks are going to feed acid or base into a waste system, so that way we can neutralize the threat if that's what we need to do. Okay, and then over on the right hand side, you're seeing these collection tanks that are there in that picture, and those collection tanks are going to be collecting the waste that we've either treated or that we need to treat, and then what happens after that moment, we will figure that out, or there's an SOP for that, literally. So as far as neutralizing these systems, that is a pretty common kind of setup there, and acids and bases are commonly used in those waste process treatments as well for that reason. Gases can also be treated as waste. There are waste that gets generated in the gas form, not just solid and not just liquid. And those are exhaust fumes or dust. Those are gases in a way that you can breathe in. Those could be hazardous if you're not very careful. You shouldn't be maybe breathing those in. And how do we limit our exposure to those types of situations? So what happens with the exhaust fumes? What happens if there's a dust cloud? How do we make sure that we don't come in contact with that hazardous material until we get rid of it? And there's an SOP for that as well. So manufacturers will often do what we call a two-step process if there's biologicals that are present. Number one, we got to kill those cells. And number two, we pH play with those samples and those liquids to make sure that they stay dead, and that we do kind of give them a 1-2 sucker punch, so that way they are killed and they don't come back, and we are adjusting the pH to make sure that we can safely maybe dispose of them the proper way. So as you see from the diagram here or the schematic, the waste stream is coming in and it's going into this tank. It's probably like a mixer in here, keeping it churned up, keeping it doing what it needs to do, properly mixed, blah, blah, blah. And there's a pump and a valve that's probably going to suck it out of there, and a valve is going to be turned on or turned off, and that's going to go into a second tank. And in that second tank, we're going to apply some heat, we're going to apply some base, we're going to apply some acid. We're going to do what we need to do in order to neutralize this threat, kill it all out, and make it safe for disposal. Just like the other one, there's probably some type of pump and some type of valve that's going to suck that out, and we can turn that flow on and we can turn that flow off as needed throughout our disposal processes or our techniques. Biological waste. Again, this is the main waste that gets generated from bioprocessing, because that's what this definition is all about. Taking something biological in nature and producing something from it, so that way we can harvest it, we can clean it up, we can purify it, we can bottle it, we can package it, and then sell it to a consumer. We cannot release live cells, and we cannot release live viruses into just the Cape Fear River. That is not how this process is supposed to work. So you got to take extra steps, you got to take extra care when it does come in contact with bioprocessing types of production. We've got to make sure that if they are present, they are totally and fully dead, and we've got to kill them, and they've got to stay dead. So those are going to be impurities. That's going to be involved in our waste. We need to make sure we check that waste. That way, when we dump it or when we dispose of it, we are not putting anyone at risk. All of that material is what we call organic load. So we hope that the organic load has been neutralized and taken care of. And if it has, then okay, we can then treat it in the next stages. But we've got to make sure that all of this stuff is killed out first. No live cells, no live viruses can be used in the waste disposal area. We can't just dump those. And again, I hope that makes better sense. Organic load, this does include the dead material, okay? Not just live, but dead material. That is an organic load. So it's still present. We didn't make it disappear. We just killed it. So when we killed it, its little lifeless bodies are still there and it's still present. And maybe we do need to filter that. Maybe we do need to process that in some form or fashion. But by definition, that is part of the organic load that we talk about in these types of situations. And that organic load, depending on what it is, can actually be sold and the company can make profit off of this. So it is not uncommon for a company to sell it as fertilizer, for a company to basically give it to something out like fish for the fish to eat and take care of that waste for them. I mean, these things are kind of common, even within the state of North Carolina, they're very common. Some of these manufacturing companies will make extra money based on the waste that they are producing. So our very last slide in our very last lecture video, technicians are responsible to handle waste. Maybe that could be your job. So there's a couple of things that we want to do. Number one, we want to just double check the valves. We want to make sure they're closed when they're closed and they're open when they're open. Two, we want to avoid the clogs that can happen. We want to make sure that things are flowing going into the areas for treatment and going out of the areas once they have been treated. Number three, coordinate operations. Number four, monitor the flow rates, as you can expect. Number five, wear the proper PPE, personal protective equipment. And number six, please stay informed. Stay informed with what you're working with what they're producing, with all the things that go on into this type of situation. You want to be aware of the circumstances and your surroundings. So stay informed of every step of the process. Why are you doing what you are doing? What is the importance of your job? That is a very special little piece of nugget of information that I think all of us should carry on our shoulders because it would help us appreciate our job a little bit more. All right, so with that said, woo, doozy, what a number of videos that we had to go through, right? I mean, we're probably totaling 26 or 27 personal videos that we have made together that we have sat and listened to with module number 5 that focuses on equipment and the utility piece of a biomanufacturing sector. And then there are probably all these little external videos too that were shared for you to watch to gain a little bit more insight into the areas that maybe people struggle with, that they need to know a little bit more information about what really is clean in place and how is that different than sterilization in place. What is a centrifugal pump or what is a diaphragm pump? I mean, these are things that we have discussed, that we've went through together, and sometimes having someone else describe it to you and showing it to you, maybe through another video, is going to be a little bit more helpful than sitting and listening to me for 30 minutes on a lecture video of where I'm just doing a blah, 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 all that waste coming out of my mouth. And now you need to treat it the proper way, which means you need to ace these tests that are going to be showing up within Canvas that you need for your certificate. Come on, folks, you can do it. I've got faith in you.